Good afternoon. This is Don Nagy, and I'm going to tell you tell you about the CCRI eMuscles and how they work. What I'm going to do is, you should have had a form just before this to show an agenda. So what we're going to do is we're going to walk through the path of the eMuscle technology, and then why CCRI uses these eMuscles, and then we're going to think about the muscle contraction design as the human structure does, and then we're going to do 3 videos to show you how the muscles work in each individual, and then we're going to do an eMuscle assembly and check it out. We're going to find out why Flexinol is the metal of selection instead of nitinol, which also works, and the source of Flexinol, which is here. Alright? Okay, this is called shape memory metals, and way back prior to 1940 is when it was first applied. It's a crystalline structure, and basically, in layman's terms, what happens is when the metal, a fiber, a single wire, is warmed, like up to the 130 degrees that we're going to be using, the rhombic shaped crystal then becomes a square, and thereby shortening the length of the wire slightly. And it's about the same as the human muscle. CCRI has chosen to use the eMuscle for many reasons, and we'll be covering them later. But the big one that we got is the human arm. Your arm has 23 degrees of freedom. That means this being a degree of freedom right here, a joint. And when you do the muscles, the eMuscles, you can develop this 23 degrees of freedom. If you choose to use motor designs, the most you can get out on the end of an arm is about 10 degrees of freedom, because you're using up the end of arm tooling is using up the payload, so you end up with no payload. Another big feature of these eMuscles is these are all actuated by electrical current. We don't require compressors or anything else. It looks really good. Now this part's going to be a little bit of a, if you're an engineer, you're going to have to do a design think change. Okay, we're going to think in this design muscle contraction design as in the human structure. The eMuscles only contract, they don't push. Human muscles contract about 8%. It's not very much, but it's enough to make them operate as they do very well. The eMuscles contract up to about 6%. Human muscles operate at 98.6. That's our body temperature. The eMuscles we've selected run at about 130 degrees. They'll run between 120 to 140 degrees Fahrenheit in order to make the actuation. They operate in pairs, and so does the human muscles operate in pairs. When the muscles are not energized, our human muscles go limp. Okay, and this is a feature of the eMuscles. They also go limp, so you can back drive the muscles just like you would your own. So I can take and go like this and back drive the muscles. Another big feature is the human muscle operates at very low voltages, and the eMuscles operate at about 3 volts. We're supplying 12 to it right now, but it's pulse width modulated. We're going to take a look first at a curve motion, and this will be the shoulder here as it moves like this. Alright? This next upcoming video is the arm, this motion going upward. Okay, now this one here, you'll hear a beep sound, and that's where the software is taking over and is causing the actuation to take place. And this is about maximum speed. Okay, this is the muscle itself. This is one that's been removed. It was this is the joint, and this is the material itself, and this is the other contact here at the end. This material is flexible, see? Just like our muscles are, but it only contracts, and then when it's limp, when it's off, it's very limp. It's a sandwich form, and it's got, I'll show you the close-up of this. This one here has about 4 or 5 wires on it, or fibers, and a normal muscle has about 70. Each wire lifts about 1 pound. if you check the write-ups that I'll show you at the end, this Flexinol, it operates like we operate at 98.6. This operates at 120 to 140 degrees. Up to 120, it really doesn't do a lot of motion. And then at 120, it starts to contract. So you take the temperature from room temperature up to 120, and then when you go to actuate the muscles, it contracts. And what happens is this pulls against there. See? This will pull that down. Okay? It's not much use above 140 degrees because there's just very slight actuation. Now we've selected Flexinol over nitinol. And they're both the same technology. They're both the same pieces of metal. The difference is in manufacturing, is when this wire is manufactured, this crystal, is the regular nitinol has a bubble occasionally, and that causes a hot spot, and it just breaks right there, so it gets fatigued. On the Flexinol, all they've done is been able to produce the wire without those breaks or those voids, and that takes them up to well over 10 million cycles. That's it. Flexinol is a material that's manufactured here in Irvine, California. May not be manufactured, but they're headquartered here in Irvine, California. I left the website available on page number 1. It's usually used for stints. The more popular one is whoever has an Apple computer out there already is using some of this wire. And it's used for the DVDs, the player, when you push the eject, that's what releases it. So there's not a solenoid or motor that's releasing it. And one last thing is there's references for other websites. See you later. That's it. Thanks.